Good morning, everyone. Thank you so much for joining us this morning. This is the second in the Seed Talk Series 2021, New Varieties for Western Canada. It's we, the Saskatchewan Seed Growers Association, is hosting it in partnership with the Manitoba Seed Growers Association and the Alberta Seed Growers. A couple notes. Everybody will be on mute during the presentations and the Q&A sessions. If there's an echo, someone has both their phone and computer audio on, so press the pound and your participant ID on your phone and your computer audio will be disconnected. If you're having difficulties, text Jeff at 403-975-9981 or email him at jeff@colesag.com. And this seminar is being recorded. How do you ask a question? You put, there's a Q&A where you can type in a question at any time and it'll be sent to the panelist for response. It might be live or it might be typed, or you can raise your hand. If you have a question during the Q&A, just raise your hand and the host will unmute you. You need to remember to unmute yourself on your computer, press your microphone icon or press *6 on a phone. And then when you're done, mute yourself again. And this is where the raise hand is. It's down in the, it might be at the top, might be at the bottom. It depends how you've got your screen set up, but this is the raise hand. And then you click lower it when you're done. If you're on a mobile device, you type in pound and your participant ID and then pound, and you'll see the webinar controls at the bottom. Same as in the graphic that's above. So the agenda for today is we're going to start with an introduction of the breeding team at the Crop Development Center in the Department of Plant Sciences with the University of Saskatchewan. And then Bunyamin Taran will give us an overview of the University of Saskatchewan crop varieties. Following that, there'll be an introduction of the Agriculture and Agri-Food Canada breeder team. And then Hamid Naim will give an overview of mustard, oat, barley, and pea varieties. That'll be followed by Richard Cuthbert with Ag Canada, who will talk about the Ag Canada wheat and durum varieties. And then Richard will do a presentation on some new wheat breeding technologies, and that will be followed by the Q&A. So this morning, we're going to start, as I said, with Bunyamin Taran. I will turn it over to you, Bunyamin, and you can request the share screen.
Good morning, everyone. I hope you can hear me well. If not, please let me know. Okay, so my name is Bunyamin Taran. And first, I'd like to thank you for the Saskatchewan Seed Grower Association for the opportunity for me to share what we are doing here at the University of Saskatchewan, and also to introduce to you the new varieties that are released by the program at the university. Okay, so let me first introduce you who we are and then what we are doing. Okay, the first one is Aaron Beatty. Aaron is in charge of the breeding of barley and oat at the Crop Development Center. As you see, mostly he's working on the improvement of agronomic quality on both barley and oat, disease resistance, and quality as well for both crops. The next one is, everyone knows, Curtis Posniak, mostly working with durum, high-yielding spring wheat breeding and genetics. Okay, so Curtis is also our director. Just recently, he's taking over the position as CDC director, and also he has a new assistant called CDC manager. So kind of some restructuring happening at the CDC. So he's working mostly with durum wheat, developing high-yielding cultivar. So you can see he has some lines for release this year. The next one is one of the senior, Pierre Hackle, mostly working with spring wheat breeding and genetics, spring spelt, alternative wheats, and also canary seed breeding program at the University of Saskatchewan Crop Development Center. Okay, you can see here briefly what it's doing with the spring wheat. Cultivars will improve yield, maturity, disease resistance, of course, shorter straw, early maturing varieties, and introduce unique wheat germplasm for alternate use suitability for the Saskatchewan environment. And one of the newer breeder we have is Dr. Bill Biligatu. Bill mostly working on forage crop breeding and genetics, including alfalfa, sainfoin, crested wheatgrass, hybrid broomgrass, all kind of, he look all over potential legume and grass and other species for forage for Saskatchewan and Western Canada. And then Dr. Tom Workenting, mostly working on field pea breeding and genetics for yield, agronomic, and recently he also involved some quality, for example, to produce high protein field peas on different market classes, yellow peas, green peas, dun peas, and some kind of maple peas. And Tom also working with the soybean breeding for Saskatchewan in collaboration with a number of programs in Canada, for example, from the Ottawa program, and also some germplasm from the Iowa program. So he's doing a little bit smaller scale than field peas, but this is coming. And myself, my name is Bunyamin Taran. I'm mostly working on chickpea breeding and genetics, both the Kabuli and Desi type of chickpeas. And recently, I'm also in charge for the flax breeding program. So there's possibility that I will be taking over the flax program and merging it with chickpea. So I'll be responsible for both chickpea and flax breeding at the CDC. Within the department, there are also two other breeders outside the CDC. There are two structures. One group under CDC, what we call SRP, mostly funded by the government of Saskatchewan. And there are breeders in the department kind of outside the CDC. So these include Bert Vandenberg, mostly working for lentil, breeding and genetics, all kind of market classes in lentil, from red lentil, green lentil. Within red, there is kind of different seed size and the green as well, some French green lentil. So all kind of market classes within his program. And he's also reviving the fava bean program. So fava bean has been like kind of long crop in here, started in the 1970s by Dr. Gord Rowland. Before he switched into flax, he was working with fava bean. Now kind of Bert taking over that fava bean and revive the program. So it's getting kind of traction there. And then Dr. Kristen Bad, mostly working with common bean breeding, and he's also doing some genetics and genomics on the lentil as well. Okay, so that's who we are and what we are doing at the Crop Development Center and the Department of Plant Sciences, University of Saskatchewan. So if you are interested or need more information, feel free to contact any of us. So now I'd like to continue with the new and potential variety release for 2020 and 2021 for this annual meeting. Okay, the first I'd like to start with the barley. This is from RNBT. You can see the name in the top right corner, who's the breeder. So 2019, there was one varieties was released under the name, the ID HB17340, and it was named as CDC Valdres. This is the Turo Hollis food barley. This variety is distributed by Tomtin Seeds. Okay, the check for this is CDC McGuire. So this CDC Valdres 5% lower yield than McGuire, but it has other kind of competitive attributes. For example, it's good for resistant to smut, intermediate to stem rust, net blots, and spot and fusarium head blight. It has very high beta glucan, very good straw strength, and short plants. And then there's one barley line supported for registration in 2020. This is FB209, and its proposed name as a CDC Renegade. This is the 2-row forage barley. It will be distributed by Sican. The check for this is a CDC Cowboy. So yield, forage yield 5% higher than Cowboy, similar maturity, moderately resistant to surface smuts, stem rust, Fusarium head blight, and intermediate to net blotch. Okay, higher protein and a little bit lower ADF and NDF compared to Cowboy. It has a smooth on and high grain yield with lodging similar to CDC Cowboy. So that was the two cultivar released in the last 2 years. And then Aaron indicated that he will bring one candidate of barley, 2-row feed barley, and then 2 oat milling. So this kind of in final stage of evaluation hasn't decided yet, but he will bring it to the next PGDC meeting sometimes later this month. Okay, so this is the program. The next one is Spring Wheat by Pierre Hackel. So it's kind of released recently a number of varieties with different kind of advantages. For example, 2019, he released 2 CWRS. One is already named as a CDC SK Rush, IDSPT 599. It will be distributed by Sican, and then there are 4 others. They will be 3 of them will be distributed by Proven Seeds, and 1 will be FP. Okay, and 2021 potential, he will bring this 3 CWRS, all very strong yield compared to the Carberry. For example, PT 5003, 14% higher than Carberry. And the next one, BW 1085, 9%, and BW 5062, 8% higher than Carberry. Maturity varies, mostly 1 to 3 days earlier than Carberry, and height equal to Carberry, similar with disease reaction. And then the last column here is kind of really what is kind of the advantage of this any of this unique new line potential new varieties. For example, compared to CDC Gold, it has a 50% reduction in Fusarium head blight, FHB, and Dawn, improved leaf rust for the first one. And the second one, B1085, as M1 carrier, is a cross between Carberry and Atmos. And the third one, BW5062, it has 2 genes for clear field. So it has a strength uniquely for each one of these. So this will be kind of proposed in the next PGDC meeting. And moving ahead to the room by our director, Curtis Posniak. So he released this one. He named it as a CDC Defy. The ID is DT1004. It's very high yielding compared to strong field. You can see here in area 1 and 2 and area 3, 4 in about 10% higher than strong field. Okay, protein about 8.8 lower than strong field. There's an improvement in lodging. Okay, good for lodging, moderately resistant for stem rust. Okay, intermediate for stripe rise, and moderately susceptible. So there's an improvement there for Fusarium head blight. Okay, and a little bit taller than strong field. So this will be is distributed by Sican. And the other 2 potential for the 2000 this year PGDC meeting. The first one is DT1012. Okay, so this is one of the first semi-dwarf as a replacement for AC Navigator. So you can see here, for example, on the column yield compared to strong field. Okay, it's higher than strong field, and if you compare to the same class, AC Navigator is about 10% higher yield than Navigator. And you can see plant height quite similar with Navigator. couple days later than the navigator for maturity. It's very good for lodging. Okay, on a scale 1 to 9 is scale 1. Okay, test weight kernel is about the same, and also same package for disease resistance and improvement for DON content. Okay, so you can see on the last table, okay, DON content and Fusarium head blight index, it's much lower compared to AC Navigator. The next one is DT1014. So this is compared to strong field, 5% higher yielding. And then you can see on the right, for example, there is an improvement for the disease package here. For DON, for example, one of the lowest, okay? And also for Fusarium head blight. So this is combining for higher yield, acceptable maturity, very high test weight, and then low DON and Fusarium head blight mycotoxin for DT1014. So these two will be brought to the next PGDC meeting. The next one is a field piece program by Dr. Tom Warkentin. So he will be proposing these two yellow piece, 4947-2 and 4900-13. So the check for yellow piece is a CDC Amarillo. And these two cultivar are very high yielding potential on almost in the north and south growing regions or areas, with the average about 7 to 9%, with similar maturity with the check, similar lodging score, and improvement on seed breakage score. So from fair in Amarillo, and these two candidates have a good score. And protein, one is higher and the other kind of about similar. Okay, and then the green one, CDC 4506 is a green piece with 4 years station data. It's very strong yield in the south. Okay, and about similar to the check with Amarillo in the north growing region. Medium maturity, good seed breakage, good for bleaching tolerance, and proteins about similar to Amarillo. And the next one is on my crop, chickpeas. So there are few available now for chickpeas. For example, Lancer was released 2019 and Orkney 2020. Medium, large Kabuli compared to B90, very strong yield all across, larger seeds, and improvement or similar with the check for the Ascocaeta. And then this year we have a small Kabuli release and also large Kabuli. So you can see here 2021 CDC 3652. There's a yield penalty, but this is one of the largest seeded Kabuli available, so about to 10, 11 millimeter seed size with a similar package for Ascocaeta. And then there are two specialty chickpeas released, 2021 to 510 Desi, and then to 570 Black Desi. This is kind of for small markets that are kind of exist in the North America and globally, so similar yield package, good for Ascocaeta. And then all these new cultivars of chickpeas have tolerance to IMI herbicide. So you can give growers more tools for controlling broadleaf weeds in crop. And the last release was from the dry bean breeding program by Kirsten Bad. So she released CDC Sunburst, improvement over CDC Sol for yellow bean, specialty market class here, and improvement in maturity, some disease resistance, and similar yield potential. And also the White Mountain non-slow darkening pinto bean, so it's improvement for CDC, WM2, and Island. So all this, the bean program seeds distributed by Rudy Agro. I think that's all what I have and released from the CDC breeding program. And I thank you for your attention. And if you have any question, please send me a note, or maybe there's some discussion later in this program. Thank you.
Thank you very much, Bunyamin. If you have any questions, you can put them in the Q&A. We will be addressing them at the end of all the presentations. Now we're going to move on to introducing the Agriculture and Agri-Food Canada breeders. Thanks so much for sending me the information, and we're going to introduce everyone across Western Canada. Just a short, brief review of who they are, which station they're at, the program they're involved with, and then there'll be some of the cultivars listed. Some are specific to that researcher, others are specific to the program itself. The first ones we'll introduce is Anna Badea. She's in Brandon. She's in the barley breeding and genetics program, and their focus is to develop barley cultivars for Western Canada. I'm not going to read all the cultivars. I'll let you guys look those over. I'd also like to introduce Santosh Kumar. He's a wheat breeder. He works with the CWRS Wheat Germplasm Improvement and Cultivar Development for Canadian Prairies. His expertise is fusarium head blight, new sources for midge tolerance, pyramiding rust resistance, and pre-harvest sprouting resistance. Also in Brandon is the new oat breeder, Kirby Nelson. His program focuses on sustainable oat breeding and genomics, and he looks at both conventional and organic production. And I think he just started this summer with Brandon. In Lacombe, we have Deng Jin Bing. He's a field pea breeder. He's focusing on high and stable yield, lodging resistance and tolerance to major diseases, better seed quality and appropriate maturity. And they cover all the different types of peas, the forage, maple, green, marrow fat, yellow, red. In Lethbridge, we have Robert Graff. He's a wheat breeder for over 30 years, lots of time in spring wheat. More recently, the last 22 years has been with winter wheat. His focus is on agronomics, disease resistance, and quality. And then also in Lethbridge is Harpinder Randhawa, and he focuses on spring wheat breeding, again, agronomics, disease resistance, and end use quality. Does a lot of work with the minor wheat classes, as you can see by some of the cultivars that have been released through his program. In Saskatoon, we have the mustard breeder, Bi-Fang Cheng. She works on development of high-yielding hybrid cultivars in brown and oriental mustard, and high-yielding synthetic varieties of the condiment yellow mustard, so the Synapsis alba, and enhancement of condiment mustards of the germplasm of both of those varieties, the Brassica gentias and the Synapsis alba. And there's cultivars that have been released from her program. Then from Swiftcurrent, we have Yufeng Ran. He's a Durham breeder. So he's looking to develop and incorporate resistance to wheat midge, wheat stem, sawfly, abiotic and biotic stresses, high-yielding cultivars, and some genomic strategies to improve breeding, marker-assisted breeding, and resistance to fusarium. And we have Richard Cuthbert, who's going to be presenting today, and he's a wheat breeder, so he works on developing and improving resistance to abiotic and biotic stresses, fusarium head blight, leaf, stem, and stripe rust, leaf spot diseases, common bunt, loose smut, and powdery mildew in hexaploid cultivars, and also works on developing high-yield hexaploidy cultivars, and also does work with marker-assisted breeding. And we also have Hamid Naeem, who's with us today. He's the lead biologist at the Seed Increase Unit in Indian Head. His role is the increase of seed and the maintenance of the purity of the breeder seed. And prior to his role with Indian Head, he worked on genotypic and environmental effects of gluten proteins, the effect of growing season weather on wheat quality, some projects in agroforestry, and has done wheat breeding in the past. So that's it. Quick introduction to the breeding teams through Ag Canada. It was very quick. And now we'll go forward to Hamid's presentation on the varieties from Ag Canada other than wheat and durum.
Today, I will be presenting some distinguishing features of AAFC varieties. That few of them were released in 2020, and the other ones will be offered at the PGDC meeting for approval in this year. That be at the end of February. I'll be presenting one mustard variety that was approved last year, 2 lines, and 5 barley lines and variety, and 3 pea varieties. So let's start with the mustard. Mustard variety AAC Yellow 80 came from Dr. Bifeng Chang research program at Saskatoon Research and Development Center. It's higher yielding than AAC and Dante. It's 9% yield advantage up here. It's 5 centimeter taller than the Czech. In terms of maturity and seed weight, it is similar to the Czech varieties. In terms of quality parameters, such as mucilage, oil, and protein content, chlorophyll content, they are similar to the Czech varieties. Mucilage in yellow mustard is a very good characteristics and one of the breeding objectives. It is like a xanthan gum, and it offers excellent emulsification capacity, both in oil and water systems. It is lower in glucosinolate than the Czech variety. It is 137 versus 141 units in the Czech. Our oat breeding program is from Brandon Research Center. Dr. Kirby Nielsen is our new oat breeder. Kirby took over this program after retirement of Jennifer Mitchell. 2 oat variety lines are offered at a PGDC meeting this year. They are OT 2129 and OT 7100. They have OT 2129 has a 3% yield advantage over our Summit. Plant height and maturity are similar to Summit and Camden. Lodging, test weight, kernel weight are equivalent to CS Camden. Growth percentage and beta glucan are also similar to Summit. It offers a good disease package. Consistently low scores have been recorded for crown rust, stem rust, fusarium head blight, and barley yellow dwarf virus. As both of these lines are coming from the same cross, so they are pretty similar in their agronomic and quality attributes. Two barley lines were approved at the PGDC meeting last year. These are coming from Dr. Anna Badaya's research program at Brandon. One of them is TR17255, a malting barley. It has a 6% yield advantage over Metcalf. Maturity and height are similar to the Czechs. It has a little better lodging resistance than AC Metcalf, but similar to CDC Copeland. Its malting profile is pretty good. Alpha amylase is higher than CDC Copeland and AAC Synergy. It approaches almost AC Metcalf. Beta glucan in TR17255 is lower than the malting than the Czechs. This line is licensed to Cantera seeds. TR17255 offers a very good disease package. As you can see, it's a stem rust, it's resistant, and surface-borne smuts and net blotch, it's MR, fusarium head blight and spot blotch, it's immune. Net blotch, it's immune to MS. In loose smut is the area, and the spot is where it is MS and S. The other line approved at PGDC meeting last year is TR18262. It's a feed barley. Its agronomic aspects are fairly similar to TR17255, and it also offers very good rust resistance package. Three lines will be presented at PGDC meeting this year. Two of them are malting barley and one of them is feed barley. TR18257 is a malting line. It has 7% yield advantage over AC Metcalf and 2% over CDC Copeland. It's shorter than all the Czechs. Lodging resistance is better than AAC Synergy and AC Metcalf, but similar to CDC Copeland. Malting profile is low in beta glucan, similar to AC Synergy, and fine extract is higher than all the Czech varieties. It also offers a very good disease package, resistant to stem rust, surface-borne smuts, and net blotch. TR18258 is another malting line that we presented for approval. It has 13% yield advantage over Metcalf and 7% over CDC. It's shorter in height than all the Czechs. Its lodging resistance is better than AC Metcalf and is similar to AAC Synergy. Malting profile is within the range of Czechs. Beta glucan is lower than the Czechs. As with the other line, it also offers a very good disease resistance package. TR19268, it's a feed barley line. It has 3% yield advantage over CDC Ostenson and Champion. Height is within the range of 2 Czechs. Its lodging resistance is better than Champion and similar to Ostenson. Grain plumpness better than Czechs and grain protein similar to Czechs. It also offers a very good disease package. Coming to the peas, dry peas or field peas are among the biggest special crops grown in Canada. There are different types: yellow peas, green, marrow fat, maple, and red peas. Among these, yellow peas cover the biggest portion of pea production in Canada. There are over 40 varieties of yellow peas registered in Canada. Last year, two varieties of peas were registered from Dr. DJ Bing's program in Lethbridge, Alberta. These lines are AAC Julius and AAC Beyond. AAC Julius is licensed to FP Genetics. In terms of maturity, it's similar to CDC Amarillo and but later to AAC Lacombe. It has a 5% yield advantage. Seed size and seed protein are fairly similar to Czechs. There is a higher protein than AAC Lacombe. Disease resistance is similar to Czechs. AAC Beyond is registered to Cantera seeds. Its agronomic and quality attributes are similar to AAC Julius. P0936 3913 yellow peas line will be presented at a PGDC meeting this year for approval. This line is similar in terms of maturity to CDC Amarillo, but later to AAC Lacombe. Its yield is similar to the Czechs. Seed size is significantly smaller than the Czechs. Protein is higher than CDC Amarillo and AAC Lacombe. It's resistant to powdery mildew. Thank you very much for your time and attention. If there are any questions, I will try to answer or forward it to the respective breeders. Thank you.
Thank you very much, Hamid. We will now move on to Richard Cuthbert, who is going to talk about the wheat and durum varieties that are coming out of the Agriculture and Agri-Food Canada program. Richard?
Hello, everyone. Can you see my screen?
Yes.
Okay, perfect. Thank you to the seed growers for the invitation to provide these updates. It's always exciting to give an update on the ones that the varieties that we gave an update on while they were experimental the year before, and provide some information on lines that are upcoming and we're excited about as breeders. So thank you for the invitation as usual. So I'll provide a bit of an update on the wheat and durum varieties from AFC from the presentation in 2020 January. These were some of the lines that were presented. A number were supported for registration, and there's an update here. We'll go through some of them that have been named and are of interest in the next few slides. So AAC Hodge, I believe Santosh Kumar from Brandon is quite excited about this one. It's a very nice package. It's a midge tolerant line with very high yield, more than 17% over Carberry, more than 6% over Viewfield, and a strong disease package. The FHB resistance is strong, rust is strong, bunt is strong, so that's nice to see. It's a semi-dwarf, a little taller than a Brandon. It'll be similar to a Glen if you've grown Glen, probably about a head taller than Brandon, I would guess, based on that height similarity. So this is what it looks like. I think it stands reasonably well, high yield, a good disease resistance package. So exciting line to watch. And it is licensed to FP Genetics. One that I presented last year was BW5044 at the time. It's been named as AAC Hockley and licensed to FP Genetics. This is a double haploid. Its yield is 9% over carberry, but it is a non-SM1 line, so it's midge susceptible. Very strong straw, plant height similar to carberry, quite similar in appearance to carberry, and it has a lot of similar pedigree to carberry, so we would assume that. The FHB has been very strong on it. It's low dawn accumulation and low symptoms. It's becoming a check in the FHB nurseries. So we're pretty excited about that. And it has a very strong disease package otherwise for leaf rust, stem rust, stripe rust, loose smut, and common bunt. Quite a strong package. So this could be a nice replacement for Brandon. I won't have the yield of some of the SM1 lines because it doesn't have that extra protection, but if you're not looking for an SM1, this could be of interest. So yeah, so we did Hodge, Hockley. That's what Hockley looks like. A hard white variety from Harpender, Randawa, and Lethbridge has been registered as AAC Whitehead and licensed FP Genetics. This is a very high yielding hard white. I believe it's the highest yielding hard white we've seen yet. It's 21% higher yielding than Snowstar. I think it would rival a lot of the CWRS and CPS material for yield in a head-to-head comparison. So it's quite an achievement by Harpender. It's SM1 positive, so it's midge tolerant. Maturity is equal to AAC Cirrus, which is a new hard white that's been registered recently. It's semi-dwarf in height, similar to Cirrus, which is maybe a bit taller than Carberry, but in that shorter range. And it has a good disease package as well, and stronger straw like Cirrus. So if you're looking for a hard white, this is one to take a look at. W583 is a red winter from Rob Graff and Lethbridge. The name is to be announced. I believe registration's underway. Rob's noted that it's well adapted across Western Canada, but especially in parkland regions and Manitoba. This is replacing Emerson as a check in the registration trials for the winter wheats. Strong yield, strong protein, very good winter survival. Height is semi-dwarf, equal to Elevate, which is the shortest check. Straw strength is equal to the best check, and a strong disease package again in the Russ and FHB. Bunt has been noted as S, so something to keep an eye on. AAC Weyburn is a Amber Durham from Yufeng Ruan at Swift Current. It has quite a complex pedigree. As you can see on the top of the screen, it's the number of advanced lines that were intercrossed in a four-way cross. It is the first Amber Durham that's high yielding with midge tolerance and a solid stem. So the solid stem provides protection to wheat stem sawfly. Its yield is 7.2% more than Strongfield and equal to Brigade, which is the highest yielding check in the registration system. We said SM1 positive, midge tolerant, grain protein similar to Navigator. Plant height is shorter than Strongfield and has good lodging resistance equal to Brigade. A test weight is higher than the checks, and kernel size is equal to Strongfield. So again, a strong disease package here with leaf rust, stripe rust, common bunt being resistant, stem rust being moderately resistant. The FHB is MS. We know FHB has been a struggle in the Durhams. That's similar to Caberry. So it's a nice looking line. There's a picture of it here, a little shorter than Strongfield, and the straw isn't too bad, and a nice combination of traits. So new lines that you won't have heard about before, likely. They're coming up to seek support for registration at the end of this month at the Prairie Grain Development Committee. We have a number here. There's a CWRS, targeted CWRS called PT495 from Santosh Kumar and Brandon. It yields 5% more than Carberry and more than 6% more than Parata. It's an SM1 positive midge tolerant line. It matures 5 days earlier than Carberry, so the yield may not shock you, but the maturity likely should, and it's even earlier than Parata. So that's not an easy thing to achieve, to have a positive yield increase and earlier maturity. Everything else is kind of in line. The height is 2 centimeters taller than Glen, so a little bit taller, but it won't be like a conventional height. So that's still quite acceptable, I think, but it will be more straw than a Carberry Brandon. FHB is intermediate and a strong rust package. Common bunts noted as MS, and based on CWRS, or based on testing, quality testing over the last 2 years, it looks like it's suitable for CWRS. So. There are 3 CPS Reds coming up for registration. The first is from Harpender Randawa. It's a cross of Foray, Tenacious, and Penhold, and some of those will jump out at you. Foray tends to be quite a high yielding CPS. Tenacious is a taller variety, CPS variety that was rated R for Fusarium head blight. I believe it's the only spring wheat to date to be given an R rating for FHB, but its plant type wasn't as attractive and didn't gain a lot of traction. And Penhold tends to be the CPS standard, as it's quite short, strong strawed, and yields reasonably well. So this line, HY 2090, yields 6% over Penhold and 18% over Carberry. It's a non-SM1 carrier. It's midge susceptible. Maturity similar to Foray. It's a little shorter than Foray, which is ideal. Straw strength similar to Foray and Penhold. We haven't had a lot of good straw strength data in the last few years in the registration testing, as it's been reasonably droughty conditions, which isn't conducive to lodging. Stronger disease package, notably stripe rust if it's rated R. It's FHB, Harpender's noted as MR. And it's immune to stem rust, race UG99 and its variants. The next 2 CPSs are from myself at Swift Current. Similar pedigree, it's a Syngenta CPS with SY985 with Tenacious and Penhold again. This one yields reasonably well. I'm pretty excited about the yield on it. It's 9% over Penhold and 29% over Carberry in the high yield wheat C. So the registration test it's coming out of, it's an SM1 positive, so it's midge tolerant. Maturity similar to Penhold. Its height's 9 centimeters taller than Penhold, so about a head taller than Penhold, and its lodging has been similar to Foray. FHB similar to Penhold, and stripe rust has been very good, as well as stem rust and leaf rust, so that would be an improvement for the CPSs. HY 2096 is interesting. It's a doubled haploid of Tenacious and Penhold, trying to get the FHB resistance from Tenacious and keeping the plant height of Penhold, essentially. This one doesn't yield quite as well as 2095. It's 6% over Penhold and 23% over Carberry. It's an SM1 positive again. And it's a little bit taller. It's 12 centimeters taller than Penhold. So likely about a head taller than a Carberry, but it is very, very strong straw, just like Penhold. And its stripe rust, stem rust, leaf rust, common bunt appear to be rated R, and has resistance to UG99 stem rust variants. Has improved falling number, and the quality's been in line for CPS Red. So let's see what happens with registration. A new line from Rob Graff out of Lethbridge, W601. Broad adaptation. I think Rob is pretty excited about this one. Overall yield has been 11% over the red winter check means. Higher yielding than all the red winters and special purpose checks, and special purpose tend to be more for yield. So this seems to be blowing the socks off them. So survival is very good. Height is semi-dwarf. Straw strength is better than the best check. Stem rust, leaf rust, stripe rust are R to MR. FHB's an I. Common bunts looks like an S. So one to keep an eye on. And Rob's included a picture of it here. So Two Durhams, DT 2005 is the first from Rouen at Swift Current. High yielding, about 3% more than Brigade, the highest yielding check with similar green protein. Plant heights equal to Cabri, lodging similar to Brigade. Quite a good package again. The disease package is in line, and it appears that it will have an FHB reaction similar to Brigade, which we've noted as MS star in the seed guide. The star meeting, it has attributes that are better than a lot of the MSs, but they aren't quite willing to say intermediate yet. But we're trying to provide some extra information of lines that are improved in the MS category. And DT 2009, I think Rouen is pretty excited about this one. Yields well, again, like Brigade. Protein similar to Strongfield. Very good disease package again, leaf rust, stem rust, stripe rust R, common bunt MR, moderate resistance to UG99 stem rust variants. And most notably, I think hearing from Rouen and even Curtis and Ron Knox at our program, it seems to be a pretty good improvement for FHB, and we don't want to jinx it, but it's looking like it may go into the eye. So it's one of the strongest lines to have come out of the Durham for FHB resistance. So a lot of the work that's gone into that is starting to pay off. So nice to see. So we'll keep that is the last slide for new lines to be registered. So you can pass it back to Lori.
Thanks, Richard. So we're going to move into Richard's presentation about some of the current breeding technologies that are being used to enhance the development of new varieties for Western Canada.
Okay, does this show up reasonably well still, or is it?
Yep.
Okay, I'll keep it in the same format here. Hopefully this works well. So thank you again for the opportunity to present. I think this came out of, typically these variety updates would have been done at the AGM, and with the shift to online and some changes, I think we got talking in emails about presentations that could be possible. And we're facing a little bit of an interesting year with COVID in 2020. Not everything we wanted to put in the field was possible. We still have uncertainty going forward, and makes things interesting in a wheat breeding program. And I'm sure other breeders would agree. It's causing some challenges and making us think about how we're going to achieve objectives and not lose any time to market. So just acknowledge everybody I work with. It's not a one-person show by any means. There's a number of people we work with that make these things possible, and they're listed on the screen here. Wheat breeding, I used this slide recently in a germination podcast or webinar. The perfect variety is elusive. It's very hard to achieve. That's because pathogens and pests in the field, they continue to evolve. You'll likely have heard the phrase rust never sleeps. The pathogens don't sleep. They continue to evolve, and they continue to overcome resistance that we put in to varieties. So we need to stay ahead of them, and we need to ensure we put the best combinations of resistance together into those varieties. So it's a challenge. The growing environment continues to change. We see a lot of climate extremes. If we look over the last 5 years, it's been, I don't think any year is exactly the same. There's always a challenge. And breeding is unfortunately a long-term and costly endeavor. We can't snap our fingers and just have the perfect variety. It takes a bit of time, and I'll describe that here and what we're doing to try and ensure we meet those objectives as fast as we can. So these are some of the challenges in wheat breeding. You may have seen these slides in other presentations. Traits are related. You can't just increase yield without having another trait be affected, and often that's a higher yield would mean lower protein. Higher yield can mean later maturity. So when you pull on one of these, it's like pulling on strings. If you pull on one, another one gets shorter or longer. So we need to keep those in mind in breeding. We also have what we call genotype by environment interactions. So we try to select varieties and release varieties that have assured performance, that they will be consistently high between environments, whether you're in Swift Current or the Red River Valley. We're looking for that blue line, the one that does well in different mean site yield locations. We don't really want that orange that drops right off in a drought. It only does well in an irrigated environment. And then again, evolving pathogens. And the prairies is a vast wheat growing area. There's a number of regional challenges: frost-free days, heat stress, drought, excess rainfall, access to irrigation, biotic stresses like stripe rust, leaf rust, stem rust, leaf spots, fusarium head blight, deoxynivalenol or DON accumulation in the grain, common bunt, loose smut. Pests that we focus on at Swift Current especially are wheat stem sawfly and wheat midge, and then all the market class of the end use quality traits. So I've been referring to this as the wheat breeding toolbox. So it's pretty hard to run a wheat breeding program without access to all of these tools, from the ability to do crossing. You really need to be able to do marker assisted selection. It's been in use for well over 20 years now. Doubled haploidy is important in certain cases. Access to indoor controlled environments, access to all the appropriate disease nurseries. Use of contra-season nurseries is quite important and has been for decades. It's quite a bit more efficient than using indoor controlled environments for seed increases or generation advancements. Our adaptation trialing or yield plots, having them in the right locations and sufficient testing to adequately assess performance of those lines is very important. And then being able to screen for pests, so wheat stem sawfly, wheat midge, they aren't always predictable in where they will be, and we need to be testing in those locations as we're able to. And then all the stuff that goes with quality testing. I could have a whole slide of tools in quality testing, but being able to assess lines for the targeted market class is extremely important, especially for high quality, high value market classes like CWRS and Durum. A new topic is genomic selection, and we're in the process of implementing this in the program, especially with COVID. It's forcing us to do it a little bit faster, but we were prepared for it. So that's kind of what the presentation will focus on today. And gene editing is an evolving tool that's still finding a home, I think. So just to know a brief overview of the Swift Current CWRS pipeline to put some numbers to generations. So after you make a cross, and I have some pictures of this in the next few slides, but after you make a cross, you generate what we call the F2 generation, and that's the most variable generation. Every plant is unique, and in Swift Current, we've been pretty targeted in making a lower number of crosses with parents that are well understood, and then really mining those crosses for allele combinations. So what happens in that time is we go through meiosis, and we recombine genes between the parents that we've crossed, and we search for those combinations that perform the best. And these are some numbers, and what by generation, an F2 to an F8, so that's the filial generations. By an F8 generation in bred wheat, especially we consider that inbred, where you can take seed from a plant and grow it year after year and it will look the same. If you took the seed from an F2 and grew it the next year, it would segregate out for a number of traits still. So this is really an inbreeding process and a selection process with some numbers of lines beside them. So yeah, this is more what it looks like, or crossing. We can go two different ways. From single crosses, we can go into what we call the doubled haploids, or we can go into our more diverse crosses and use another parent to cross onto those. And I don't want to get into the weeds, so we'll keep this at a very high level. But we get to this F2 disease nursery where we'll assess for simply inherited traits like leaf rust, stem rust, stripe rust, common bunt resistance, and plant type. we'll often have used marker assisted selection to skew the population for material that is more resistant for diseases like fusarium head blight, like rust resistance, and some quality traits. But it's been pretty, it's taken a couple decades to really refine this process, and it's commonplace now. And really what we're going to do is take marker assisted selection and take it to a whole new level with genomic selection. So we typically run maybe 1, 2, 3, 4 markers at a time on this material. This is what an F2 space planted nursery looks like. There's over 300,000 single plants, and breeders have said to me there's more plants there than 300,000, and it's true, but we have spreader rows for rust in these nurseries, and there's 300,000 single plants from the crosses that we've targeted. And in the red box here, I have on average, one of those plants becomes a variety per year. I think on Twitter, I've said in the past, and I've used this picture of this field. I think it was about 2004, AAC Brandon was a single plant in that field. So it's really finding the needle in the haystack. So we look at all those plants and we'll select them on plant type, leaf rust, stem rust resistance, stripe rust resistance, bunt resistance, and wheat midge quite often we'll have in those nurseries as well. This is a picture of our early DH disease nursery. So DHs, we have more plants that are, they look the same. They're from the same, they're all the same. They're all the same and in the row. So we have more plants to look at, and that becomes easier than looking at a single plant. So that's our DH nursery. And again, on average per year, 1 DH line becomes a variety. So this just, you saw those numbers before. This is kind of how it plays out from the F3 to the F8 generation. It's pretty standard pedigree breeding method. Once you have more seeds of a family together, you can start to get into the lower heritability traits like grain yield. It's pretty hard to assess grain yield, grain protein, and end use quality on a single F2 plant. But it gets to be easier when you have families. So these plots from the F4 to the F8 generations. Again, not wanting to get into the weeds, but we can currently typically look at those same entries in FHB nurseries, leaf rust nurseries, stem rust nurseries, stripe rust nurseries, common bunt nurseries at the same time. So if we were to put this into context and in some examples, you may have heard of Starbuck or Wheatland. You may be growing these varieties. We're pretty excited about them. So in the columns, we have AAC Starbuck on the left and AAC Wheatland on the right. And then their process from 2008 when the cross was made through to 2012 when they hit that F8 generation and were considered inbred. So that took 4 to 5 years. We used a number of the tools in the toolbox. We used marker assisted selection. We didn't use double haploidy in this case, but we advanced those through the adaptation testing, through the disease nurseries, using controlled environments. And in 4 to 5 years, we had inbred lines for those crosses. At that point, they went into advanced testing, and that takes roughly 5 years. You can speed it up maybe a year, but the registration testing takes at least 3 years, and you need some certainty before you put a line into that very complex registration testing, very costly registration testing, that that line has a payoff, or the likelihood of a payoff of being a new variety. And then after that, in 2017, we sought support for registration, and then it was assigned, both were assigned to CCAN, and now we're looking at commercial launch in 2021. So it is a long-term endeavor, and it is fairly costly to do all this. So I have some animation on this, but it won't work. But we generate a lot of data every year. There is a lot of commonality in parentage and crosses each year. Lines like Carberry become, we've referred to them as bulls in the program. They become reoccurring parents, and there is a fair amount of similarity in the crossing. So it kind of gets to be incestuous. A lot of the same genetics and genes are in play, and we generate a lot of data. So if we can make use of that more efficiently, along with new genomic technologies, you've heard that the wheat genome's been sequenced and new lines have been, varieties have been sequenced since. So that's what this is about, predictive breeding. Can we use a breeder chip? So instead of one marker at a time or two markers at a time, can we use thousands of markers that will adequately characterize a wheat line, along with all this data we have in the program, to better predict what we're going to do in crosses and what we can get out of them. So that's what this is doing. On the left side of the screen, we're taking our yield data, our protein data, our FHB data, our quality data, and we're putting that into populations. We're genotyping or running the lines on a breeder chip to get an idea of what their genetic makeup is. We're using statistics and putting that all together and being able to apply that to the entire program to make selections and discard what we know will very likely be bad before it even goes to the field, so we make our field resources more efficient. So this is a quick slide about implementing genomic selection. If we go back to that first slide of the F2 to F8s of 300,000 single plants assessed in the F2 to roughly 1,800 entries in the F8, how can that work? So what we tend to do is take a random subset of F4 lines along with parents and checks that are relevant, and we put them to the side. We put them in different testing and we intensively test them. So we don't throw anything out of that set. That year we do everything. We do grain protein, grain yield, end use quality, FHB nurseries at multiple locations, and any other traits that are of interest, and we really study those lines. And then we genotype everything in the program, which can be costly, but we're getting that price down all the time to into the tens of dollars per line, which is cheaper than running yield plots and all these other things. And then we can apply these models and we can discard material more strategically at an earlier stage indoors. So implementing it, 2020 was a challenging season with COVID. We weren't able to seed everything we wanted to in the field. I don't think that's a secret. Not everybody could. So some material wasn't assessed. So we're currently genotyping all the CWRS early generation material. And the picture you see behind it is a drone video of one of our winter nursery locations in New Zealand. We're pretty happy that New Zealand is COVID free. They're still working as normal. So they have a lot of our material down there, and we're implementing genomic selection on it using all the training sets modeling that we've done over the last 5 years or so. And we're applying that on this material to reduce our numbers so we can actually fit it in the fields this coming year. So it's taken some foresight, and we're very grateful to all the funding we've received from wheat producers, the Wheat Checkoff, ADF, Genome Canada's, all these projects that we worked on over the last decade to make some of these things a reality, because without it, it would be a very daunting 2021. And I think we're going to be able to make it work quite well. And we may not really miss a beat, thankfully. So with that, if there's any questions, happy to field them. Just thank you again. Thank you to the funders, all the wheat checkoff dollars that we receive, and support from the government, of course. So thank you.
Thank you so much, Richard. It's really interesting to see how that progress has improved and cut down, hopefully, in the future, the time to market for any of the new cultivars and that you're working on.
Yeah, it's unfortunately the one thing we can't really speed up is meiosis. We're pretty good with contra-season nurseries at getting to inbred lines, but it's very difficult to speed up that advanced generation testing, the registration trialing. In my opinion, it's quite risky to cut that a whole lot more than the 4 to 5 years that it is now, because when it comes out and there's these lines that we're talking about in the variety update or what we're putting forward for registration, we're asking the seed growers and industry to make a bet on those lines, and we want them to pay off. We need them to perform as they appear and not be a flop. So the best way to do that is to have those years of testing in advance, and you can't. There is no way to replace a growing season. In my opinion, it's very important.
Mhm. Well, thank you to Bunyamin, Hamid, and Richard. And now we're going to open the Q&A session. So if you have a question, you can type it into the Q&A, or you can raise your hand and we will unmute you and you can ask your question directly. Remember to raise your hand. There's the little icon at the bottom that you can use, or you can raise your hand on your phone by *6.
This is Jennifer from the Manitoba Seed Growers. Thank you for the presentations this morning. I am pleased to hear, Richard, that you were able to have a contra nursery season regardless of COVID. So that's good news.
We do have a question for Bunyamin. Do you have any comments on upcoming flax varieties?
Okay, thank you. This is a question from Jeff Owen. Thank you, Jeff, for the question. So they said there is no new cultivar. So the last cultivars released was CDC Roland and CDC. Initially, we named it as CDC Kernan, but apparently Kernan has been used for other crops, so we're gonna change it to CDC Azure. So it's in the process of amendment with CFI, but for the new lines, we don't have at this point, so we're still collecting more data. We were a little bit limited in 2020 due to COVID, so hopefully this year we'll have kind of more site that we can test it. There's some potentials in the co-op now, second year co-op, that will come into the plate. Maybe 2022, I will bring it for registration. Thank you for the question, Jeff.
And we have a comment from Tyler Wist. Thanks for discussing the insect issues, Richard, and for the presentations, everyone. And Tyler, for people that don't know, does a lot of work with the wheat midge program.
I saw the question here from Jen about flax breeding going on at AFC. There is not, to my knowledge.
There's a question from Jim Bagshaw. We are seeing more new lines with the SM1 gene. Is this a trend that will increase in the future?
I believe so. We're keeping, I guess I can answer that or chime in. Yes, a lot of the higher performing varieties have midge resistance, and typically based on the SM1 gene. That is our only mode of resistance at this point, really. A reason why those lines do get used in crossing quite often, because they are the higher performing ones. They have that yield protection and grade protection that go along with it. So in our program at Swift Current, we are using wheatland and Starbuck quite a bit, and have been, and won't be long, probably a year or two before those lines are into the registration system. Lines derived from wheatlands and Starbucks and Elidas. So they're coming quickly. Typically, we're identifying lines that look quite promising to use as parents when they're in that advanced testing, going into the first years of registration testing. So it's the faster you can cycle the best parents through the system, the better your rates of gain will typically be. You just don't want to make a wrong bet on them. So it's kind of like poker, but knowing some of the cards. So it's card counting, I guess. That makes sense. So yes, there will be more SM1s. I should say that we're also being proactive in making non-SM1 crosses to ensure that we have better lines to use as refuges in the SM1 varieties. So lines like Hockley that have come out that have very good disease packages, a strong yield and a strong plant type and in-use quality. We're keeping our eye on those to make sure that the farmers that want a non-SM1 or we need updated varieties for refuge, they're available.
Okay, thank you, Richard. There's another question from Michael Shichuk in the Q&A. And I'm just going to read it because I don't think any of the participants on the phone can see the questions. So from what I saw, AAC Wheatland VB was first crossed in 08. It's now finally commercially available this year. So roughly 13 years to market. Using today's breeding technology, how much can this timeline be shortened?
That's a good question. It was crossed in 2008, and we had the inbred lines finished testing at the F8 generation in 2012, I believe. So that's roughly 4 to 5 years of the core breeding effort. After that, it was advanced testing. So if we were willing to make the bet, we probably could have cut a year off that. Cutting a year out of the initial development, getting it down to 3 to 4 years, it's possible, but we did concurrent early generation testing and field seasons the entire time. So there is no magic wand for speeding up variety development. If you go and search right now, something that's hit the news, popular media, is something called speed breeding out of Australia. They've really taken near ice nil development, so what we call single seed descent. You make the cross and you just keep taking a seed off each plant and regrowing it in a greenhouse using lights that are on basically continuously, and you try to cycle it as quickly as possible. So they say they can get to 4 to 6 generations per year cycling, but no selection will have occurred unless you're using genomic selection. But using genomic selection, you need to also be doing those training sets in the field in real world conditions. So it's a tricky thing to do. You can't replace a field season in my mind. I think it could work in certain cases, but to ensure that performance is there, the way those were developed, I think the proof is in the pudding a little bit. They're both strong varieties. They took as long as they took. In hindsight, we could cut a year or two off, but we'll always have hindsight. So when we give a variety or a new line that's been supported for registration over to a seed company, we really want to make sure that it's going to perform, because you're putting a lot of money into it, and we need it to pay off for you.
I have a question for about other crops. You've shown us the process for wheat. So Bunyamin and Hamid and you, Richard, are there many differences between what you're using with the wheat and what some of the other crop types are using to advance their varieties?
So I can answer some of those, Laurie. So the principle is quite similar to what Richard has described in wheat. And how we use it, that may be different from different crops. For example, the routine one that we are using in pulses, in lentil, in chickpeas, in field peas, for example, tolerance to herbicide IMI. So we use a scratch cotyledon from the seed. So in individual F2, before we grow them in the field or in crossing block, we get part of the cotyledon, just very small amount, and then with crude DNA analysis, and we know before even we grow the seeds that the plants will be tolerant to IMI or not. So that will save us time. So only that's with 99.9% accuracy, because we only looking into one kind of switching in the DNA sequence. Okay, so that's one thing. So that's for kind of simple trait that can be easily done at early generation. For the complex traits, like Richard described, we need to have a strong phenotypic data as well. So that kind of a little bit more complex than it is. So the same thing, we are adopting this technology, kind of we refine it. What is the best strategy to apply this across different crops, in chickpea, in lentil, in peas, and I'm sure in other crop as well, in barley, with RNBT and oat as well. So very similar approach that's been done. And really depending on the application on trade per trade basis. Some can be done easily at the early generation, some you need a longer time, as Richard said.
Thank you, Benjamin. Richard, there's another question from Lyndon Stahl. Is yield still the #1 priority, or are you starting to look at abiotic stress resistance, i.e. drought, flooding, root resilience, etc.?
That's an excellent question. If we release a variety, the yield needs to be competitive. I guess in my opinion, it wouldn't matter how attractive the root system was if it didn't put some bushels in the bin that was competitive with what was already being grown, unless it was in a very drastic year, it likely won't get the traction. So yield needs to be competitive. I think there's probably a bit of give and take on what we call biotic resistances. I think farmers will make the decision on, is an MR for FHB good enough for an extra 5% of yield, or do you want if an R was available for FHB resistance, would you take a 5% yield penalty? So I think as breeders, we try to keep those things in mind when we're making our selections, making our crosses, and planning the programs in future years. But I think the question I probably get more than half the time is, what's the yield? So I think yield's still a very high priority, and yield isn't just yield, it is the combination of all those things. So at Swift Current, one of the members of the team is Jatinder Sangha. He's a physiologist. He's been doing a lot of work on a line in our program called AAC Goodwin that was derived from a cross of Carberry and AC Cadillac. It seems to have quite high stable yield, and some of his preliminary work on it is identifying that it has a lower, on the leaf surface, stomata, the organelles that allow exchange with the outside environment. Essentially, they have an important role in maintaining moisture in the plant and regulating those processes in the plant. And he's finding that Goodwin has a lower stomata count or stomata density on the leaf. So we are getting into those things. Testing for them is quite laborious. Yield plots are still a pretty good way to go, and they're reasonably cheap to do, but we are trying to refine some of those methods to be able to select for more physiology traits that are important in the various growing regions that we're targeting on the Canadian prairies. So hopefully that helps.
Great, thank you, Richard. There's actually a question from Hamid in the answer section. He's asking, are contra-season nurseries used for pulses? I don't know whether Benjamin or someone could address that.
Yeah, so in pulses, we use different places as a counter-season or winter nursery. For example, for lentil and faba bean, we use the nursery in New Zealand together with other crop like flax. And for field peas and chickpeas, we use the winter nursery in Yuma, Arizona. So that's a little bit closer and kind of quite manageable. We can still be able to visit before COVID, I mean. Yeah, we do use that winter nursery every year. That's one way to help us to cut the generation advance in the breeding program. Having said that, we don't do any selection in those winter nursery, mostly just for generation advance and seed increase in those two winter nurseries. Thanks for the question.
Thanks, Benjamin. It appears that we don't have any more questions. And so I'd like to take this opportunity again to thank Benjamin Taran with the University Crop Development Center and representing Plant Sciences Department as well and Hamid Naim from Agriculture and Agri-Food Canada, and Richard Cuthbert, also with Agriculture and Agri-Food Canada, for their presentations today. We certainly appreciate everyone that has participated today. As we mentioned at the beginning, this is going to be recorded, or it is being recorded, and we will be putting it up on our website. So if you've talked to anybody who missed the program and wants to revisit it, then that's where it will be. We want to, I'm trying to move my slide here. I want to talk about our Seed Talk series. This was the second in our series. We've got 3 more coming up. They're every second Thursday at 9 a.m. The next one is going to be about seed quality across the prairies, and that is going to be presented by Discovery Seed Labs. We will have representatives from Alberta, Saskatchewan, and Manitoba updating us on what's happening in their areas. And then Mike Harding is going to talk about the bacterial leaf streak. That's on the 25th. On the 11th, we're going to have Seed Growing 102. That'll be presented by Bayer Seed Growth. And we're going to be having experienced producers or seed growers give us some tips and tricks to help some of the newer seed growers in our industry. We're also going to have discussions with some inspectors on what they would like to pass along as some of their tips and tricks when it comes time to inspections. And we're going to do a little showcase of our new interactive seed guide on that day as well. And then the final one is going to be on March the 25th. It's a CSGA 2.0, where we're going to be discussing a lot of the initiatives that CSGA is embarking on over the next year, and that will be presented by Westland Insurance. I want to say thank you again to our sponsors for this year: Bayer Seed Growth, Discovery Seed Labs, Westland Insurance, CCAN, Syngenta, FP Genetics, Lewis M. Carter Manufacturing, SGS Canada, Nextseed, CropLife Canada, and Canterra Seeds. We very much appreciate your support for all of our activities this year. As I said at the beginning, this program is a joint initiative between Saskatchewan, Manitoba, and Alberta seed growers. So if you have any questions, you can contact any of us at these emails or websites. And again, I want to thank Richard, Hamid, and Bunyamin very much for their presentations today. And we hope that you enjoyed the presentation. Thank you. Goodbye.
Thank you. Have a good day, everybody.
Thank you.
Thank you very much.